This is a mixed circuit tutorial. The first step to doing a mixed circuit tutorial is drawing out your circuit on a separate piece of paper. I already drew mine out before I started the video. The question is, the source has a voltage of 6.0 volts. Each resistor has a resistance of 12.0 ohms. Find all the other values of current, voltage, and resistance. My next step is to write what I have and what I need. So how I do that is I write C, I, and R by the source and the resistors. Since it's the source, I will write P as a subscript, meaning total, and I will label each resistor by writing the number as a subscript. So this would be resistor 1, so I'll give them the subscript 1. This is resistor 2, so I will give them the subscript 2. And this is resistor 3, so I will give them the subscript 3. Make that a bit bigger. Okay. So the next step is to fill in what I already have. So my given values. So my battery has a voltage of 6.0 volts. And each resistor has 12.0 ohms as their resistance. 0.0 ohms. 12.0. Alright. When you just have the voltage of the battery and the resistance of the resistors, the first step you will do in solving the mixed circuit problem is find our parallel, which is for R2 and R3. So I do 1 over R parallel equals 1 over R2 plus 1 over R3. So 1 over RP, RP is short for our parallel, equals 1 over 12.0 ohms plus 1 over 12.0 ohms. I'm going to rearrange that like this. So 12.0 to the power to negative 1 plus 12.0 to negative 1, all to the power of negative 1. And this is how you rearrange this type of equation for our parallel. And this will give me 6.0 ohms. Now that I have our parallel, I can solve for our total. Our total equals R1 plus our parallel. Our parallel is just replacing R2 and R3, which would usually be here. So R1 is 12.0 ohms plus 6.0 ohms, which will give me 18.0 ohms for my total resistance. So 18.0 ohms. Okay, now that I have voltage total and resistance total, I can find current total by using Ohm's law. Ohm's law is R equals V over I. So I rearrange the formula for I. So I equals V over R, which equals 6.0 volts over 18.0 ohms, which equals, I'm going to punch that into my calculator, 0.33 amps. And I write that right there. The next step, I can find I1 because I know IT equals I1.
So therefore I1 equals 0.33 amps. Since I have two values, I can solve for V1 now. So V1, looking back here, V would equal R times I. So V1 equals R1 times I1, which equals 12.0 ohms times 0.33 amps, which equals 12 times 0.33 equals 3.96 volts. But looking at significant digits, I know that my final answer will be 4.0 volts. That is what I write up here. Now that I have that, I can solve for V2 and V3 by V series equals V1 plus V parallel. And V parallel stands for V2 and V3 because they are both the same in this case, because they have the same resistance. So V series also stands for total voltage, or the source, or VS, which means the source of the voltage. So 6.0 volts equals 4.0 volts plus VP, which means V parallel. So VP equals 6.0 volts, subtract 4.0 volts, which gives me 2.0 volts for voltage parallel. Now that I have that, I know that VP equals V2, which equals V3. So V2 equals 2.0 volts, and V3 equals 2.0 volts. So I can fill that in right up here. Now that I have two values, I can solve for I2 and I3. So I2 equals, looking at Ohm's law, when I rearrange it for I will get V2 over R2, which equals, so that would be 2.0 volts over 12.0 ohms, which equals 0.17 amps. And I already rounded it for significant digits because my calculator gave me 0.16666. So I already rounded it for significant digits. And I3 would equal I2 in this case, since they both have the same voltage and same resistance, but I will prove that. Which equals 2.0 volts divided by 12.0 ohms, which gives me 0.17 amps. Alright, so now I look at significant digits. All the voltages have the same number of significant digits. Same with the current, and same with the resistance. So this is how you solve for a mixed circuit problem.